I want to welcome all of you to this particular presentation. As you can see at the top of this slide, NewEra has big ideas and may seem somewhat self-serving, but I hope as we go through this, you'll get an impression that we do think out of the box and we try to bring you tools and processes that can help you to better maintain the integrity of the ZOS environment. So let me move on here. Obviously, over time, you probably recognize that SAE and Image FOCUS and the control editor and ICE have brought you, along with others, IBM and other software vendors, a number of different tools that you have layered on to protect and defend the integrity of the ZOS environment. Our big idea essentially is that preparedness is everything. When it's game on, which is likely a constant state from your perspective, having the right tools and defenses in place essentially is everything. Over time, we've seen additions to the tool sets, things like passphrases, multi-factor authentication, pervasive encryption, ZERT, just a number of things just keep coming and coming and coming to protect that integrity. And new things are now on the horizon. With ZOS 3.1, IBM made available to us a tool called Secure Boot. And I want to talk to you today in some detail about Secure Boot and its relationship to Zero Trust. And then about halfway through this presentation, which will take about 40 minutes, we'll drop into an actual product demonstration. So what is Secure Boot? Well, the big picture, a lot of words here, but let me point out the most important ones, is that in a secure boot environment, only trusted software can be executed during an IPL. And that's critically important. Obviously, it's important because you don't want any malicious software finding its way into the IPL stack when it's implemented or initialized on your computer. And so in order to do that, what Secure Boot essentially attempts to do is to place limits on trust, much like Zero Trust does. And as it does that, it does it not with a virtual environment, but with an actual physical environment that's referred to as a clean room. That clean room, in turn, has characteristics to it. It's an isolated system with very limited access. So it's really secure. It's really limited. It's really the clean room. It's where everything is going to take place, that where you are going to receive deliveries, perhaps an LPA list, a nucleus. You're going to receive them, you're going to modify them, and you're going to sign them. That's a new issue now, signing. And then you're going to pass them on to an HMC, where it in turn is going to follow a process that will lead to a new form of IPL called a list-directed IPL. So we have three elements then in this structure now at this point at this big picture level. We have the supply chain. This is the series of linkages and events that ultimately result in the ZOS deliveries that you receive. We have a process of signing, which we're going to refer to as validated boot. And then we have output from that signing process, which is sent to the HMC to perform a list-directed IPL, which is sometimes referred to as a secure boot. Now, if we drill down into that a little further, essentially we can see what we mean by supply chain. Now, in this case, I'm using countries to demonstrate the different linkage points in the supply chain itself, but it could easily be divisions, it could easily be departments, it could easily be individuals in a development team delivering components from their work onward to the work of others. Of course, as each one of these is delivered, there becomes an issue of making sure that the provenance, that is, that the sequence of custody that's associated with each of these elements remains intact, so that when it reaches the end of the chain, the receiver will know that it came from a trusted, reliable source. And so as you look at this now, the clean room doesn't really represent much of a change from what you do today. You receive elements from shop Z, you put them into an environment. In this case, it's described as a clean room, but it could be your current operational environment. You modify them, you make additions to them, you validate them, hopefully with the authorized code scanner and hopefully with Image FOCUS before you move them on for production. But in the new world, this is what's going to happen. There's going to be another step, a signing step. And remember, that signing step is what we refer to as validated boot. And what it will wind up doing is placing a fingerprint on all of the elements that you deliver to production. And that fingerprint will be controlled by an infrastructure that contains certificates and key rings and permits and et cetera, et cetera. Once that process is complete and your deliveries are attempted to be IPL'd, again, remember the new form of IPL called a list-directed IPL, that fingerprint will be validated against each of the components. And if a problem is found, you could operate in what's referred to as enforce mode, where the system would enter a wait state, telling you, hey, there's something wrong with this particular module. It doesn't comport with the fingerprint that we expect to find within it. Or you could be in audit mode, where it simply says, hey, I found something, it doesn't look right, but I'm going to keep going. You figure it out after the fact. Or obviously, it could always be that things are okay. So let's go over that again. Today, this is pretty much what the picture looks like. You make modifications, you make additions, you validate, hopefully with Image FOCUS, and then you pass things on for an IPL. In the secure boot world, you're going to take that extra step, create that clean room, and perform a validated boot. That is, you're going to sign all of the elements. You're going to give them specific fingerprints, and you're going to pass them on for a new form of IPL, which is referred to as a list-directed IPL, where this operating system can enforce or audit or say everything's okay with those components relative to that particular fingerprint. So let's go a step deeper now. If we were to set up a clean room, what you see on the left side of this screen are the elements that would be necessary in order to build that infrastructure. At the highest level, you can think of it as, okay, well, it's a key ring and it's some certificates. Well, you got to get down in the details of that because that key ring is going to be permitted by two special RACF profiles, one in the facilities class, one in your data log class. Those certificates themselves, we recommend two, a signing certificate as well as a CA certificate, are going to wind up being created in a very prescribed way, and their public-private key pairs are going to be stored in ICSF in the PKGS data store. That whole process ultimately will permit some individuals, that is, those people who are permitted by our data log, to actually perform a signing. And that signing will result in signed resources. Then there are three things that have to be moved from that point forward once we have the signed resources. We'll have to pack copy them over to the production KEX. We'll have to export that certificate that was used to sign those resources over to that KEX. And we'll have to pass forward documentation about that signing process so that the fingerprint that was used by the certificates to actually sign the resources can be known to those who are managing the HMC. So on the right-hand side, then, things look like this. The certificate's moved over, and using ZOSMF, it's imported into the HMC. There is a validation step between the import of the certificate and HMC's display of the fingerprint so that we can map it back to the documentation. And then from there, the components are moved, the fingerprint and the certificate are moved to the individual LPARs, where using a new loader called the VBoot loader is used to actually load the components and conduct the list-directed IPL. One caveat in all of this is that there are lots of moving parts for sure, but it requires storage class memory. So you have to sort of keep that in mind if you're attempting to perform this step. So what's important here? What's the most important thing to take away from this slide? This is the most important thing: documentation. If you don't have the appropriate level of documentation of the actions that were taken during the validated boot, it becomes confusing over time to know what fingerprint goes with what certificate created in what process by what user. So that documentation is more than just passing over the name of an export data set and then having it imported into the HMC. There has to be a step of validation here that provides us with, again, the provenance, the continued focus on that supply chain, that we know that what it is that we're about to do from the HMC's perspective actually comports with the components and the resources that were signed in that clean room. Going another step further, there's all kinds of documentation that I recommend that you follow up with. All of that just linked here that you can spend some time on. Probably the single most important document on this page is this document that was created by Kevin McKenzie, who is a validated boot test architect. It explains in detail all of the steps that are necessary in order to appropriately validate the components, sign the components, and pass them forward to the HMC so that they can be used with a secure boot. So going further now, have you gotten lost now by this point? Are you sort of, oh my God, this is sort of like overwhelming? Well, it is. My friend Jim Lautner and I spent quite a bit of time studying this and trying to understand it. And there is some frustration that you will likely feel as you attempt this for the first time. If your choice is to use conventional TSO ISPF interface and go to option 6 and start issuing commands, you're going to be busy for a while, trust me. And at the end of it, the frustration associated with the inability to actually conduct the signing may put you in a position where you say, well, maybe this isn't worthwhile. Maybe it's not worth my time. Don't fall prey to that. Stay on it, because this is something that's going to be continuously in the forefront of improving the integrity of ZOS over time. Things like NIST and things like DORA, things like PCI, things like GDPR, all of these various rules, regulations, all point to these kinds of processes for ensuring the integrity of the operating system. Keep in mind that Secure Boot has been in place for quite some time, not on ZOS, but in other operating environments. This is pretty much standard practice. And so I think we can expect that we need to hone our skills here and figuring out how this works and how we can do it efficiently so that we can not only implement it, but we can support and maintain it over time. So if you were to take another approach, if you were to go to that 3270 environment, instead of going to option 6, you would have typed on the command line TSO $CLI, comma, asterisk VB dot admin. As an administrator within the ValBoot environment, you would find the panel on the right-hand side. And from this panel, through a few entries, ValBoot will create for you not only the key rings, but the profiles associated with them, permit users to them, and then create the certificates that are to be associated with them. Administrators in the ValBoot environment can build, test, manage, and monitor the ValBoot configurations, while signers and auditors get their own unique view. Stated simply, ValBoot provides controls that ensure role-based integrity over it, so that administrators have one set of rules that can be followed, auditors have another set of interfaces that they can follow, and signers have their own to validate that their structures, in fact, are operational. Now, here's just a summary of what it is we will see when we get into the demonstration. On the left-hand side, what we see is a panel that has been populated with the commands that are necessary to build a key ring. In this case, the key ring will be owned by a group, and that group is sys1. You get a pointer here. You can see that up here. Now, you might be asking yourself the question, wait a minute, I know better than that. A group can't own a key ring. That's true, it can't. But you can set it up inside of the ValBoot requirement, inside of inside of RACF, by simply creating an ID, like a regular user ID, that will be associated with that particular group. Another layer, if you would, another detail of complication that is associated with this process itself. All of the issues, all of the resources that are necessary to make that key ring, once it's added, operational, including our data log class profile, facility class profile, the APPL data component of that facility class profile, all laid out here on the panel for your review. Now, when you click on the Add Profile, Submit, and Keyring launch point at the bottom of the panel, it will then take you to another panel that will allow you to generate the commands that are associated with the certificates that you want to add to the keyring. You want to connect to that keyring. And ultimately, you can generate those, and when you are done, you will have completed a complete structure. How long does that take? A couple of minutes. How long does the review take of the work that's being done under the covers to generate those commands? Longer, because you'll want to spend time reviewing how these commands are put together and what they're actually doing to make sure that it's doing what you expect it to. Now, behind each one of those is a trace so that you'll always have that information available to you. Once we have a structure built, as you can see at the top, of a key ring and the facility and our data log class profiles and certificates attached to the key ring, we then need to do two things. We need to obviously document that signing certificate and pass it on to the HMC with a public key. And then what we need to do is perform a signing. We need to test to make sure that that structure actually exists. And to do that, we use a program provided by IBM that's referred to as IEW Sign. IEW Sign responds to 3 different params: sign, unsign, and report. So if we start here on the exec card and we say, let's submit this job, IEW Sign, when its action is signed, is going to first make a call to a service that is going to parse out through the facility class profile that profile that best fits the calling user. And there are many, many different forms that that profile can take. Our view, Gemini's view, after studying this for a couple of months, is that the one that is likely the easiest to understand, support, and maintain over time is the profile that specifically identifies a given user as an extension to the default requirement that the profile be named IRR Program V2 signing. If we do that, then it becomes clear in the RACF data store which users have which profiles and how those profiles relate to the key rings and certificates that are being used by them for their signing. We recommend that very highly. Once we've identified the profile, and again by name, then we have to look inside that profile to identify the APPL data component of it to extract information that relates to the key ring itself and to the R data log profile that's being used to protect that key ring. If we find it, the next thing that's going to happen is that our data log profile is going to be queried to determine whether or not the specific user that's calling for it is actually able to have either, excuse me, alter or update access to it. If it does, then it continues on to validate the certificates to make sure that they have the appropriate profiles in the CSF keys class so that they can be used in the signing itself. Now, you can do these signings with a single certificate, but we recommend two: a CA certificate, obviously a certificate authority, that will be used to sign that signing certificate itself. Now, that's sort of like a belt and suspenders kind of way of doing this, but we believe it's the most secure way. And since it's relatively simple to do inside of ValBoot, there's no reason not to do it. And so at this point, then, we have now not only built a structure, but we've now used IEW sign to actually sign that structure. When that process is finished, we're not done by any stretch of the imagination. All of you know that once you get involved in certificates and key rings and the various permits and controls that are associated with them, it's not a one and done kind of activity. You have to then, from that point forward, be in a position to maintain them and to audit them. And so in the case of ValBoot, administrators will have available to them a toolbox, a set of options that will allow them to evaluate all of those components, manage them, monitor them, alter them. For example, what do you do when that signing certificate begins to approach the end of its useful life? How will you renew it? What is it that you will do to accomplish that task? What happens if there turns out to be some sort of disconnect between the key ring and a given certificate? Perhaps it loses its trusted state. What will you do? How will you fix that? How will you even identify that that particular problem has occurred? So, tools for the individual roles and users: administrators, full tool set, and access to an important component in ValBoot called the VB structures. This is a summary of all the operational structures that exist within the validated boot environment. And so you can see here, for example, we begin by describing each of the key rings and then the R data log profile that protects those key rings, the users who are permitted to those key rings, and what user access they have, pointing out those that may have, for example, none or read. The minimum is update. And also defining those key rings that are associated with groups, for example, the build group or the sys1 group. But our recommended profile are key rings that are defined with an extension that associates with an individual user. For example, again, Jim Lautner's keyring JLOC1. We'll see that again as we get into the demo. So admins go that way and get that final structured view, but auditors go directly to the structured view. So an auditor who is interested in this signing process wants to know what profiles are out there, what keyrings are out there, what users are permitted to those. This is a fast path to it. Simply log on to TSO as an auditor within the ValBoot environment, and you come straight to this panel. So that's the big picture. In some ways, it appears that there's not much changing, that there's going to be sort of minor changes to turn your current operational environment into a clean room. But when we drill down into it a little bit further, and we add to that process of receive, modify, validate, and add to it sign, all of a sudden we find ourselves in a situation where signing means validated boot. And validated boot means setting up the structures that are necessary to have the appropriate keyrings and certificates that can be used to sign components before they're passed on for production. So in this short demo, we have a use case. We're going to log on as an admin. We're going to build a keyring. We're going to generate some certificates. We're going to attach them to the keyring. We're going to test the structures. We're going to document those structures. We're going to export the signing certificate. By the way, we record all these events that are going on in the ICE control journal so that there's a complete, again, provenance of all the activities that have gone on to maintain the integrity of the supply chain from A all the way to our Z. We're going to renew a certificate that's about to expire, and then we're going to see those renewals in our renewal registry. So let me close my session here and bring up a 3270 session. Okay, so let me back out of here. So here's a 3270 session, typical. You know, if you're the hardy person and you have all the years of experience to be able to do this, you can just go to option 6 and start issuing commands. Jim and I tried this, and we used to say to each other when we did this first going back a few months, we said, good luck, okay? No, just good luck, okay? There's a lot here that has to be done in order to make this operational. But it's there for you if you want to, or you could just create some JCL and run a job, and that would be great. But remember, the key issue here is not just doing this. The key issue is managing it over time, being able to audit it over time to make sure that that provenance and the continuation of its usefulness is maintained. So the way in which we do that is simply go to the command line. Now, it could be at this panel or any panel, NISPF, and type TSO, $command line interface, comma, ValBoot, VB, and I'm logging on as an admin. Okay. Now, that's my panel. But let me back up here just for a minute. Supposing I was an auditor. Now, here's my panel. So the roles that are played inside of the ValBoot environment, administrator, auditor, signer, are all controlled by a facilities class profile, which is controlled by the administrator. So the administrator controls that access by role by permitting individuals to the various profiles that control administrators, auditors, and signers. So I'll back up now, go back to my command line. Now, we believe in inspection, right? We believe in preparedness. We believe in making sure that you know what's going on. And so you'll notice about mid-level here on the right-hand side, there's something that says warning. And what that's telling us is that there's something wrong with the certificates that are associated with the key rings that are being used in validated boot, which essentially might mean that one of them is about to expire for one reason or another. We can look at the key rings that are available right now. And we'll see that one of them, this one here, belongs to my friend Jim. And it's currently functional. Everything is good about it. There's nothing really of concern. So we're going to go ahead and delete it because we want to rebuild it. So I'll go ahead and delete the key ring. Always has a trace behind it so you can see exactly what it was that that was done on your behalf. So now we had 4, but now we have 3. We'll come back here because we all know in RACF that deleting a key ring doesn't delete the certificates. So we'll go ahead and delete those. Notice that all of these certificates have different identifiers on them that say KEC build, KEC gem, KEC sys, KEC admin. This is an important thing to keep in mind, that if you have a lot of certificates that get created to support individual users, it's critically important to not only identify what KEC they might be used in, but also what user is actually associated with that particular certificate. And don't rely on the owner. The owner is going to be the person who created the certificate. The user of the certificate is actually the person who owns the key ring to which the certificate is attached. So this ownership is not significant in that regard. So I'll get rid of this one. Go ahead and delete it. And we have another one down here, a CA certificate. We'll delete that. Okay, so Jim's done. All right. So we deleted the key ring, but when we deleted his key ring, we also deleted the facility class profile that was associated with it and any permits to it. We also deleted the RDataLog profile and any permits to it, and that's gone now. When we deleted the certificates, we not only deleted the certificates, but we deleted any profiles in the CSF keys class and permits to it that were associated with that certificate. Remember, these certificates by default will be stored in the PKGS. And so cleaning everything up becomes a critical issue if you're going to do some work. You'll notice on the right-hand side here that it says 030. What that means is that this particular certificate is going to expire in 30 days. And this is the reason why we have a warning on the previous page. All right, so now we're ready to build a structure. Okay, so the structure has to be a key ring and the certificates that we put on it, and all the permits and other things that are associated with that. So in order to do that, what we're going to do is we're going to type Jim's user ID here. JLOT1. We're going to click this so that this low-level, excuse me, qualifier ID will become not only a part of the key ring name, but it will also make Jim the owner of the key ring itself. Now, at this point, that's all we need to do. We just simply go down to the bottom, click on Update, Create Profile, and Permit, and here we have it. Here's our RAC dcert command to add the key ring. Jim's the owner. Here's his suffix as a low-level qualifier. Here's the RDataLog class profile associated with that. Here are the permits that are associated with it. You can see that it put Jim here. It's just trying to tell us that by default, Jim is going to be added as having access to this, in this case with Alter. But if we wanted to, we could add other users at this point and permit them. Here's the facility class profile that's necessary. Here's the name of that profile. You can see Jim's user ID attached to it. Here's the APPL data that's associated inside of that profile. You can see we use hash 512. That's the default. That's the recommendation from IBM. You can see that we have the name of the key ring as well as the name of the owner inside of the APPL data. Remember, when we were in the big picture, I said, hey, listen, IEW sign is going to first try to figure out what facility class profile best fits the user who's attempting to do a signing. In this case, the best fit is the profile that has Jim's user ID associated with it. So it looked down through the list. It said, Jim's trying to sign. Let me see if I can find something. Oh, the most specific one is Jim. We got him. Let's look and see what key ring he's using. Oh, we got him again. Great. So now we have the specific identification, the ability to be able to track him. If we set this up as a universal profile, which we can do, and we'll show you an example of that, or we set it up as a group profile, which we can do, and we'll show you an example of that, confusion might reign as to which of these profiles is actually the one that IEW sign is getting back when we call that special R-class service. It's hard to figure out. This makes it relatively easy. Let's add that key ring now to the RACF data store. Okay, that's done. Here's our trace. You can, of course, look down through this to see if anything went wrong, or you may have some criticism of the way in which we did it. We're open, obviously, to that. If we PF3 back, the next thing that we'll see is the keyring worksheet, which now tells us that we've added Jim's keyring. And at this moment, there's no CA certificate and there's no signing certificate. So we need to go do that. You can always see these worksheets from many different points of view inside the ValBoot environment. So now we're back to our major panel. So now we have to create a certificate. Now, what's the best practice for naming a certificate? Well, in the ValBoot environment, the default name is always validated boot, either .ca or .sg. And you might ask yourself the question, why? Well, in the RACF data store, there may be hundreds, maybe thousands of certificates. And when we do a query to find out which ones of them are related to validated boot, that naming convention helps us to narrow the scope of the search to just those that fit within our context of certificate naming. There's an extension that can be added to that. We recommend CECJL1. That is, that this would be a KEC that's under the control of Jim Lawton. Now, the cert auth certificate, the CA certificate, and the signing certificate have to have the same extensions. And the reason for that is because the signing certificate is going to be signed with the CA certificate. And so at renewal time, that is at the time at which we want to renew that signing certificate for whatever reason, we have to know without fail what certificate authority originally signed it. Now, you could go outside and get a certificate authority from wherever, SSL.com or wherever you want to go, GoDaddy, whatever. Okay, do it. But you're not going to do it with this, all right? We have a very prescribed methodology, and this is how it works. And we can't see, or at least we haven't been able to see, why there would be any significant value to going outside and getting a signing, getting a CA certificate from some other third party. Costs money, adds complications. Don't do that. We don't recommend that. We have to give these common names, just like we would in defining any certificate to get the appropriate subjecting. So we're going to call this JL1 name. These don't have to be the same, but I set them up the same. Or now notice a lot of things are set up in this panel to make it easy just to go. Okay, you know, it was sort of like in a drag race, go. Well, by default, the CA certificate's going to have a 5-year life, but you could change it to 6 just by over typing that. No problem. The country is US, but you could put in whatever you want here, 2-digit, no problem. The minimum for a signing certificate is 1 year, but you could change it to 2 if you wanted to, or change it to 5. I don't recommend that because that's not a good practice, because if over time that certificate loses its viability because it's aged out, it's so old now that we've forgotten what it is or how it works or who owns it or whatever, it's better to keep your, shall we say, your friends close, okay? We need to do that. So now we have all the detail that we need in order to generate a certificate. Now, our key ring is already defined up at the top. You can see that, JLOT1. Go ahead and do this. So here are the commands that are necessary in order to generate the certificates. We're going to use RACF to generate a cert hot certificate. And we're going to use GenCert to create a certificate that's owned by me. I'm the owner of the certificate. I'm the one who created it, not Jim. I did this, okay? So that at some point in time, as an admin, if I want to see what certificates I created, I can easily query the RACF data store to pull my certificates forward for my review simply by telling it, just give me the ones that are owned by me. All of the characteristics are here. We have the label, obviously. Importantly, we have the size of the key. This is an RSA PKDS size 4096. It'll take a few seconds to generate that, by the way. And we're going to sign this signing certificate with that certificate. So here's the command to do that. We're going to give it a label, obviously. We're going to give it a useful life. And we're going to put it into the PKDS with a key format of NIS, excuse me, elliptical curve size 512. Okay, we'll go ahead and issue those commands. Now, like I said, this is going to take a bit. A 4096 key size is a pretty good size key, but okay, so it did it pretty quick. Let's see what we have in our trace. Looks like everything went forward the way we would expect it. If we expect that RACF is going to give us a reply, or any reply, whether we expect it or not, we always put it in the trace. But if there's no reply, we always say, hey, we didn't get a reply. RACF is notorious for not replying when things are good. I guess you can't blame them for that. That's a good thing. When we PF3, we can see now that the key ring that we built for Jim now has 2 certificates attached to it. The CA certificate, here it is, and the signing certificate, which we call the CG certificate, is here. And we can see that it's been added as a default on the key ring. So this structure now is ready to go. So if I PF3, and I go to management tools, and I go down here to the bottom and say IEW sign. Let's sign for Jim. And I hit enter. I now get a panel that says, hey, the signing user here is going to be Jim Lawton. In this case, he's not in a Connect group, so we don't have to fill that out. He could be in a Connect group. Remember, I said we can set these up for groups. Not a recommended practice, but we can set them up for groups. We can manage them that way. The session owner is me. We're going to sign sys1.svc log. Now, we can sign anything. As long as it's a PDS and has undefined format, we can sign them all. Nucleus, linked list, you name it. Or LPA list. We can sign them. Or LPA live, I should say. And others that are surely going to come along. Vendor software, other software targets, other operating system targets from IBM are surely going to come along. And we can put them in this list and we can sign them. But this may not be your preferred way of signing in real life. What this is really intended to do, we can do the other, but what this is really intended to do is to test the signing capability of the structure we just set up. So let's test it. Click signing. Now, we generate the JCL that's going to be submitted in the foreground for this particular issue. There are some issues that will have to be addressed if the administrator is going to test the signing for individual users. There'll likely have to be a surrogate profile, and the administrator will have to be permitted to it. Some of you won't like that. You won't do it. I don't blame you. It could potentially open up a vulnerability, but you could be working with the user directly at this time. And remember, the user has his own interface. So he can easily simply log on as a user and go directly to the panel that I just showed you that will allow him to test the signing. Not you do it, but he does it for himself. But I've got surrogate access to Jim. We know each other well. So I'm going to sign for him. So I'm going to go PF3. It says, yeah, you want to keep doing that? Yes, I do. Lots of pop-ups are going to occur here because there are lots of steps. So everything completed successfully, but this first report that comes out of IEW sign with the action parm doesn't really have very much information. It simply says, yes, this was successful. Well, okay, I get it. It's successful. Probably works, but what was it that made it work? If I hit PF3, I could post this now to the control journal and bag out of this, but I'll keep going. The next thing we're going to see is a brief report that we call the signing report that could be posted to the control journal if we wanted to do that. I'll hit PF3 again. Comes back and says, yes, this was all successful. Now, excuse me, we're going to run IEW sign with action report. But remember, now we have a signed component. That signing component is sitting in a data set that has my user ID with the suffix extension to it, ValBoot sign sys1 SVC line. That's there, already signed. This guy is going to analyze that. PF3. Okay, so now we have another report. And this report has a lot more information in it. For example, it shows us module by module whether it's signed or not, and the date on which it was signed. It shows us the algorithm that was used to hash the signing. It shows us the value, SHA-25512. And importantly, it shows us the fingerprint. But this fingerprint is not really very valuable at this point because it's not in the format that is ultimately going to be displayed by extracting the fingerprint from the certificate at the HMC. It's just not there. Now, you can do it, but it's not there and it's not obvious. So if we PF3, it's going to say, do you want to show the signing detail report? That's our report. Okay, what are those messages up at the top? Those are some complaints from ICSF that have to do with setups that revolve around other products we have. I can't get rid of that for the demo. But if I hit enter, we now have a signing report. And so in this case, we can see that we're signing for user Jim. The report's actually created by me. That the digital certificate information is for me because I'm the owner of the certificate. The actual label is this. Remember this text JL1? That's the name of the signing certificate that we built for Jim. If we page down, we can see the fingerprint now in the format that will be used at the HMC to validate that this certificate is the one that we want to use. We can see the key ring. We can see what's on the key ring. We can see the PKDS meta information about the certificate as its label is stored in the PKDS under this PKDS label name, same as the certificate. And the key attributes that are associated with that storage, and whether or not there is a private public key pair in the PKDS. And it's there, we can see it. That's what this told us this was all about. And the usage, it's used for a handshake. PF3. We want to export the certificate. Okay, well, this worked. Let's send this over to the HMC. Okay, let's do that. We have an export registry that tracks all the exports. We can track the exports by version if we choose to. The versioning, which is an extension to the export data set, is by date and time, or you can change it to essentially whatever you like. We can click on select to export the certificate. Now, this is what RACD Search certificate export output looks like. So we have a export data set name, and we could tell our friends at the HMC, hey, go pick this up. It's going to be cool. Import that into your system. This is all you get. You don't get any more than this. You get this uncoded version of the certificate, or this coded version. That's it. That's what you get. Or with PF3, you could get this. Something that says, hey, this is it. This is how we got it. This is what its uncoded or its coded form looks like. And this is what its uncoded form looks like. And so that thing that I told you that was the most important in the relationship between the, excuse me, the clean room and production, that documentation, this is what I meant. Either you can get that coded version of the certificate and guess, I guess, or you could get this, which is what I think you should get, and see the complete picture of what's associated with what you're about to import into the HMC. We're going to PF3. And we could post a summary to the control journal. which we didn't do, and we're out. All of the activity that I've undertaken that you're seeing here is all being recorded in the control journal. And so the signing that we just did, if I want to show that, all that information is available to you. And the one step that I missed here was to record the actual documentation that I brag so much about. Shame on me. So I hope you get the general idea here. It's not just building the infrastructure itself. The idea is that over time, you're going to have to learn how you're going to support, manage, and audit that infrastructure in such a way as to be able to do it simply, easily, and to, I'm around here somewhere, oh, there we go, comport with whatever requirements you might have in your organization. So by now, you can see as we wrap this up that you can use ValBoot to build the structures. You can use ValBoot to test the structures, document them, export the certificates. We didn't do a renew, but you can renew certificates, and you can obviously post all of this information and keep a permanent record of it to the ICE control journals. The next step, simply send an email to either Andrew or Sammy at support@newera.com and keep the game on. Keep the game on and request a one-on-one session where we can go through this in more detail. We can arrange for the delivery of ValBoot. It's a really simple thing to add if you're an Image FOCUS user or control editor user to your existing portfolio of NewEra tools. The final word is come by and see us in Kansas City. You're going to be at SHARE August 4th through 9th. We're going to be there, and we really would like to see you and talk to you more. We're going to be in the Technology Exchange, booth 512. We have a couple of sessions, a lunch and learn on Monday. Come by. We'd love to buy you a sandwich and maybe a milkshake. And a partner exchange on Tuesday at 1 o'clock. Both of them are in room Muse, M-U-S-E-B, okay? Both are in Muse B. All right, thank you very much.
Paul,
Okay.
you did have one question that came up
Yeah,
before
sure.
you log off here. We had someone ask, what happens if Jim is no longer an employee and his RACF ID is removed?
Well, if he's no longer known to the system, then any attempt to update anything or use any of the componentry that's associated with him becomes non-operational. I think that's pretty much standard RACF fare. We're constantly checking with RACF via RACD cert as to whether or not these structures are valid. And the highest level of validation is at the individual user level.
Wonderful. Thank you so much. Thank you, Paul, for the presentation, and thank you for everyone who joined us today. I will be sending an email with these slides to the email address that everyone provided during their registration. And like Paul said, if you have any questions or would like further information, feel free to email at support@newera.com. Me or Andrew would be happy to get that set up for you. Thank you so much, and you guys have a wonderful day.